Hey, today, we will discuss Python 3 important data structures which are list, tuple, and dictionary. And then we will see how to convert these to dataframe. And how to save as files. This helps for every stream. In example, lists are mutable and denoted by square brackets. Tuples are immutable and denoted by parentheses. Dictionaries are key-value pairs and denoted by curly braces. To run this code, you should have Jupyter Notebook installed along with the necessary libraries, such as pandas. You can install pandas using the command pip install pandas in your Jupyter Notebook cell if it's not already installed. Python offers various data structures, including lists, tuples, and dictionaries. Lists are mutable collections of items, allowing for modification by adding or removing elements. Tuples, in contrast, are immutable collections with fixed elements that cannot be altered once defined. Dictionaries, on the other hand, are unordered collections of key-value pairs. Each key must be unique, and the values can be of any data type. These data structures can all be converted into pandas dataframes, which provide a convenient tabular format for data manipulation and analysis. Once converted, dataframes can be saved to files for further use. Here's a summary of the key points. Lists, mutable collections of items. Tuples, immutable collections of items. Dictionaries, unordered collections of key-value pairs. Dataframes, tabular format for data manipulation and analysis.
Here's an example using Jupyter Notebook. First, importing libraries. Here, we import the pandas library and alias it as PD. Pandas is a powerful library for data manipulation and analysis. Then, creating a sample list. List is a mutable, means ordered collection of items. You can add, remove, or modify elements in a list. We create a list, my_list, containing sublists, where each sublist represents a person with their name, age, and city. Next, converting list to data frame. We use the pandas data frame constructor to convert the list into a tabular structure, data frame. We specify column names as name, age, and city using the columns parameter. Lastly, displaying the data frame. Finally, we display the resulting data frame, df_from_list, in the Jupyter Notebook. The data frame is a table-like structure with columns and rows, where each row corresponds to a sublist from the original list. So, in summary, this code creates a pandas data frame from a list of sublists, each representing a person's information, and then displays the data frame in the Jupyter Notebook. Now, let's do the same with the tuple. While tuples are immutable, meaning their elements cannot be changed once set. In the context of data analysis, both lists and tuples can be converted into pandas data frames, and then the data frames can be saved to files. This we will discuss in the last. First, creating a sample tuple. Here, we create a tuple, my_tuple, containing subtuples. Each subtuple represents a person with their name, age, and city. Next, converting tuple to data frame. We use the pandas data frame constructor to convert the tuple into a tabular structure, data frame. We specify column names as name, age, and city using the columns parameter. Lastly, displaying the data frame. The resulting data frame, df_from_tuple, is displayed in the Jupyter Notebook. It's a table-like structure where each row corresponds to a subtuple from the original tuple. Certainly, just like lists and tuples, dictionaries in Python are another data structure, but they are unordered collections of items, each item being a key-value pair. Unlike lists and tuples, dictionaries are not sequences but rather mappings. Each key in a dictionary must be unique, and the values can be of any data type. Here's an example of creating a dictionary, converting it into a pandas data frame. First, creating a sample dictionary. We create a dictionary, my_dict, containing key-value pairs. Each key is a string representing a column name, and the corresponding value is a list containing data for that column. Next, converting dictionary to data frame. We use the pandas data frame constructor to convert the dictionary into a tabular structure, data frame. The keys become column names, and the lists of values become the columns in the data frame. Lastly, displaying the data frame. The resulting data frame, df_from_dict, is displayed in the Jupyter Notebook. It's a table-like structure where each row corresponds to a set of values from the original dictionary. This code showcases how to create a pandas data frame from a dictionary, where each key in the dictionary becomes a column in the data frame. The resulting data frame is then displayed in the Jupyter Notebook. Now, saving these data frames to files. We use the to_csv method to save them as CSV files. First, saving data frame from list to CSV. Here, we use the to_csv method to save the data frame, df_from_list, to a CSV file named list_dataframe.csv. The index is equal to false parameter ensures that the index column is not saved in the CSV file. Next, saving data frame from tuple to CSV. Similarly, we use the to_csv method to save the data frame, df_from_tuple, to a CSV file named tuple_dataframe.csv, again ensuring that the index column is not saved. Lastly, saving data frame from dictionary to CSV. We use the to_csv method once more to save the data frame, df_from_dict, to a CSV file named dict_dataframe.csv, with the index is equal to false parameter. Finally, in the result, after running this code, you should find three CSV files, namely list_dataframe.csv, tuple_dataframe.csv, and dict_dataframe.csv, in the same directory as your Jupyter Notebook. Each file contains the data from the corresponding data frame. This code demonstrates how to save data frames to CSV files using the to_csv method in pandas. Adjust the file paths and names as needed for your specific use case. This is all about list, tuple and dictionary and data frame and saving file.